120 light years away from us, there's an exoplanet that can potentially host life. It's called K2-18b, and it's a world you'd want to visit. K2-18b isn't exactly like Earth, it's more like a super Earth. Yeah, it's 2.6 times larger and almost 9 times more massive than our planet. Scientists think it could be a Haitian exoplanet, which is just a fancy way of saying that it likely has a hydrogen-rich atmosphere and is covered in liquid ocean. That means that K2-18b could be home to alien life. Only it would take a really long time to get there. If you were hurtling toward this space rock from Earth, you'd reach your destination in about 1.3 million years. Yeah, you heard right. Million. K2-18b has a lot of methane and carbon dioxide in its atmosphere. That's not exactly breathable air, so you'd still need a spacesuit to walk on this world. And I wouldn't be too hyped up about its ocean either. If an exoplanet has liquid on it, it doesn't mean that the liquid is water. It could be methane or ammonia, even acid. Like even in our own solar system, there's a moon covered in liquid lakes, but these are methane and ethane lakes, and I wouldn't recommend swimming there. K2-18b could have a pretty mild temperature. For an exoplanet, that is. At minus 100 degrees Celsius, you'd find this world incredibly cold. Now, the most exciting thing we've found out about this world is that it could have traces of dimethyl sulfide. Woot woot! Well, on Earth, this molecule can only be produced by living things, and that means K2-18b could be home to alien life. Now, it doesn't mean that this life would be intelligent. It could be aquatic or microbial. Maybe even complex life if the conditions for it are just right. We won't know for sure unless we travel to explore this interstellar world. Now, how do we know all this? Well, we had the James Webb Space Telescope look at this distant world and take detailed measurements of its atmosphere. Most of the exoplanets have been discovered using what's called the transit method. It's when a planet passes in front of its star and blocks its starlight. That's when scientists study the wavelengths around the planets, and some of those wavelengths can tell us what kind of atmosphere those distant planets have. The problem is, exoplanets are really far away. Trying to figure out what their surfaces are like just by peering through even our most powerful telescopes is not easy. Some scientists will argue that K2-18b isn't a super Earth at all, but a mini Neptune. And that's a bummer because, as you know, Neptune is an ice giant. And if K2-18b is also an ice giant, then the chances for alien life on this planet don't look so good. Now, you don't have a million years to travel to this world to discover it for yourself, so maybe we should look at a world that's a lot closer to Earth. Like Proxima Centauri b. Proxima Centauri is the closest star we've discovered, only 4.2 light years away from Earth. It's part of the Alpha Centauri star system, with not 2 but 3 stars orbiting each other. The exoplanet Proxima Centauri b orbits only one of these stars, but you'll still see the other 2 stars as bright dots in the sky. This exoplanet is slightly larger than Earth and revolves uncomfortably close to its host star. Luckily, that star is a red dwarf, and that's much cooler and smaller than our sun. Which is good news because that means this planet isn't getting toasted like Mercury. Scientists estimate Proxima Centauri b has an average temperature of about minus 39 degrees Celsius. That's pretty comfortable as far as alien worlds go. The bad news is that we still don't know much about the exoplanet's gravity or atmosphere. It might be our best candidate to set up an interstellar base, but It also could have a harsh environment, unsuitable for humanity's future home. It might even have an ocean of acid, or something deadly like that. The only way to find out is to travel there. And if Proxima Centauri b doesn't work out, well, don't worry, there are plenty of potentially habitable worlds out there. Like this one. Ross 128b is 11 light-years from Earth. It's the second closest potentially habitable world scientists have discovered. And it's more promising than Proxima Centauri b. The thing is, they both orbit red dwarf stars. Only Proxima b's host star is a lot more active and violent. It occasionally erupts and bathes Proxima b in radiation. Ross 128b's star is nice and quiet. And even though this world orbits 20 times closer to its star than Earth is to the Sun, it still lies in the habitable zone. Because like I said, red dwarfs are way cooler than the Sun. And by cooler, I just mean temperature. This world could have a balmy average temperature of 23 degrees Celsius. That's only slightly hotter than the average temperature here on Earth. I don't know about you, but I could settle there. Now, we don't know enough about this world to call it our new home. It likely has lots of harmful radiation reaching its surface, and its atmosphere might not be breathable. But hey, that's not much worse than Mars. With efficient life support systems in place, we could make it work. Besides, this super Earth might have its own life on it. If Ross 128b did have alien life, it could be extremely different from what you might imagine. Just think about making the first contact with an alien species. What would that be like? I mean, it could go very wrong, too. For one, we might not survive the trip to any exoplanets, even the nearest ones. So far, we've discovered and confirmed over 5,000 alien worlds. 63 of them are potentially habitable, but we just can't know for sure. Europa, the icy moon of Jupiter. A frigid world that would turn you into an astronaut popsicle. And an atmosphere that would take your breath away. Literally. Because Europa's atmosphere is so thin, it's almost non-existent. And while it's mostly made up of oxygen, this oxygen isn't breathable for you. You just wouldn't be able to inhale it in this extremely low-pressure environment. And this frozen world has a dark secret. Deep under its thick crust of ice, it might just hide life. That's why we're sending a member of our team on a mission to explore Europa and find out if anything can survive in this unforgiving environment. Chase, we need you on this one-way trip to Jupiter's neighborhood.
Mission Control, this is Chase, orbiting Europa and ready for landing. Did you know it would actually take you like 6 years to get here from Earth? But luckily, I'm already here, and I love finding new alien buddies when they're not trying to kill me.
All right, Chase. Initiate the landing sequence.
Already on it. Rico, start the landing sequence. I totally forgot.
Landing sequence initiated. 500 meters and descending. 400 meters. 100. Touchdown confirmed.
Oh, it's bright! It's bright! Oh, my eyeballs!
That's strange. Europa is 5 times farther from the sun than Earth and gets much less sunlight than we do. It must be so bright because of Europa's icy surface. All that ice is highly reflective. That, plus an almost absent atmosphere, could make the light feel very harsh. So just use the protective tinted visor and your eyes will be fine. Chase, what's your status?
Yeah, I'd say Europa's pretty similar to Earth. If Earth had no atmosphere, was covered in ice, and had absolutely no interesting oceans to see. So in short, it sucks, what if guy. I'm freezing out here.
Yeah, you'd need an advanced thermal insulation layer in your suit to keep you warm. The surface temperature on Europa is about minus 145 degrees Celsius, and it can get as cold as minus 220 degrees Celsius. It's also bathed in radiation. That's because Europa orbits so close to Jupiter, and Jupiter has a massive magnetic field that traps a lot of high-energy particles inside it. Your spacesuit would need to be able to withstand that, too.
Great.
Europa is one of the 4 largest moons of Jupiter. It's still slightly smaller than our moon, but it's a lot more exciting. Mainly because it has the potential to host life.
Looks pretty lifeless, if you ask me.
Well, it is, on the surface. Look, life needs 3 ingredients to exist on any world. The first one is liquid water. Well, Europa has plenty of that. NASA's Galileo spacecraft, which spent 8 years orbiting Jupiter, gathered some data on Europa too. And that data led scientists to believe that this moon has twice as much water as all of Earth's oceans.
Well, I regret to report that your scientist data is wrong. I don't see no water, only ice. This mission is a waste of my precious time.
No, it isn't. You don't see them because these enormous oceans aren't on the surface. They're deep below Europa's thick, icy crust. That brings us to another ingredient for life: energy. On Earth, life mostly gets energy from the sun, but that's not the case on Europa. First of all, because Europa is so far away from the sun, and secondly, because if there is life on Europa, it's likely we'd find it under the ice, where there's no sunlight at all. Europa gets its energy from the effects of tidal heating, and it has Jupiter to thank for that. Yeah, the enormous gravity of the solar system's biggest planet is constantly pulling on Europa, bulging and cracking its ice. This causes friction, and the friction heats this moon from the inside. That's why Europa's subsurface ocean doesn't freeze over like the rest of this frigid world. Europa might also have hydrothermal vents on its ocean floor, just like Earth does. These vents spew out heat, energy, and chemicals, potentially creating a habitable environment around them. The last ingredient for life is chemical elements. Most living things are made up of stuff like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And based on the data we collected about Europa, this moon's got all that. But of course, no one has ever been on Europa to confirm this. Until now.
And what's that?
Yeah, those are Europa's famous cryovolcanoes. These volcanoes don't erupt with lava, but with water and ice.
Ice volcanoes? That's sick! Oh my god. Okay. So, how do you suggest I find life here? This ice looks thick.
Yeah, you'd have to drill through it. And you'd need special equipment, like a high-performance drill designed for extreme cold, electrically powered by a portable nuclear generator, lightweight with a heating mechanism and a sample retrieval system.
Right, great. So just like the everyday stuff that you would just happen to carry around with you on your spaceship. No, I'm serious. I happen to have that on my spaceship. I have the best drill in the universe. I'm so excited to meet who's down here.
Oh, hold on. The chances of seeing any kind of life with your own eyes are slim. Because that life, if it exists, is likely microscopic. But if you get a sample of that salty water, well, you can examine it and maybe find traces of microorganisms.
That's not how I pictured this mission, but well, since we're here, let's do this.
While you can't improve the odds of seeing aliens on Europa, you can increase the opportunity of seeing more of Chase's epic adventures on What If. We've already traveled with him to Titan, Venus, even Uranus, and there's so much more we want to show you. That's why we launched our What If Explorers Club on Patreon. That's where we give you the top secret behind the scenes, extended director's cuts, mind-blowing art, epic merch discounts, and our endless love and gratitude. Support us on Patreon to get exclusive content and help us send Chase to his death. Over and over and over again.
Hey! I don't feel so good. I think I might puke.
Your body temperature is rising. You're experiencing the symptoms of radiation poisoning.
I did warn you that radiation levels on Europa are high. Even in your spacesuit, you'd still feel headaches, nausea, dizziness, all the fun that comes from radiation sickness. And all that after spending only a few hours on this moon. If you don't return to your shielded spacecraft immediately, this exposure will kill you.
Huh? Oh, no. I'm fine now. I'm good, Rico. I just need to lie down for 5 minutes.
That's a bad idea. You need to return the samples to the spaceship.
Right. The samples. I have to get the samples. This is still so sick, though.
The impact force from the cryovolcano has damaged your spacesuit. You're losing oxygen.
I should have subscribed to the top tier of What If's Patreon.
In the extreme conditions of Europa, without the full protection of a suit, you'd only have a few minutes to get to safety. In just 1 minute, severe frostbite would damage your exposed skin. After 2 minutes, you'd start shivering. Cue hypothermia. Another 10 minutes later, and you'd lose consciousness and freeze to death. Oh, wait, scratch all that. Looks like Chase's suit lost all the oxygen and he just suffocated. Now we'll never know if those samples had any life in them. Researchers have detected strange radio signals coming from deep space. These mysterious radio waves might just be bursts of cosmic energy from a distant neutron star. Or it could be that scientists have discovered a highly advanced civilization 90 light years away from Earth. So, what kind of civilization would have the ability to send strong signals like this? Well, scientists classify civilizations on something called the Kardashev scale. It's a scale that measures a civilization's technological ability to harness energy. While it's a hypothetical scale that could eventually have 5 or more levels, most scientists only refer to the first few. But don't be underwhelmed. We're the only civilization we know of, and technically, we're still stuck on Type 0. At this stage, we've managed to harness some, but not all of our planet's potential energy. We consume about 18 trillion watts of power every year, and if we wanted to bump ourselves up to a Type 1 civilization, we'd need to consume over 500 times that every second. To do this, we'd need to harness, store, and utilize all of the energy available to us. That includes all raw materials and every bit of sunlight that reaches Earth. We'd also have to tame volcanoes, earthquakes, and other natural forces. At the rate at which we're developing now, it's possible that we could be a Type 1 civilization within the next 200 years. But whatever civilization scientists may have discovered in the far reaches of space could already be a Type 2 civilization, or higher. Once our civilization has all of the energy available on our home planet under control and we graduate to a Type 1 on the Kardashev scale, then we need to take the next step. Time to crank up our energy consumption to 10 billion times what it was before. To do this, we'd need to harness not just all the solar energy that reaches Earth, we'd need all of the energy our star generates, period. If there is a Type 2 civilization out there, they're probably using an incredible system to do this: a Dyson sphere. They'd build this megastructure around their star to collect all the energy it radiates out in every direction. They could even assemble other Dyson spheres around the first Dyson sphere to guarantee that little to no energy escapes. But there's nothing simple about this technology, and that's why only advanced civilizations could construct something like it. For one, a Dyson sphere must be larger than the star itself. And if these megastructures are bigger than stars, well, they should be easy to spot, right? Well, this could be tricky. Once a civilization is finished building the Dyson sphere, the megastructure blocks nearly all of the visible light from its star. A civilization this advanced could make its own solar system invisible. Lucky for us, visible light isn't the only way to detect a star. Even with a Dyson sphere blocking its light, a star would still radiate heat, and we could detect the star by the infrared light it gives off. But that wouldn't be the only way we might discover a civilization this advanced. Remember that strange radio signal? It originated about 90 light years away from Earth, coming from the star HD 164595. Was this powerful radio signal created by an alien race and intentionally pointed toward Earth? A civilization able to pull this off would need to be far more advanced than our own. This Type 2 civilization would be able to utilize the raw materials on every planet in its star system, and maybe even beyond. They may have built fusion reactors that orbit their planet, fueled with gas from other worlds with hydrogen-rich atmospheres. And they might be mining precious metals from rocky planets, just like Earth. They could terraform other planets into livable worlds for their populations, and they wouldn't live in fear of civilization-ending natural disasters like asteroid impacts, ice ages, or global warming because they'd have technical solutions for these too. This alien civilization would be at the stage on the Kardashev scale where they'd be able to master interstellar travel. But if that's true, there should be no reason for them not to pop by for a visit, right? Well, not so fast. With all the advanced technology they might have at their disposal, these aliens could be waiting for us to catch up. That way, when our civilizations meet, we would do so as equal partners. Who knows? They could be so advanced that they're no longer a fully biological race. They could be more like cyborgs with a mix of robotic and organic material. This would make them capable of incredible things that humans could only dream of. But they wouldn't stop there. An advanced world like this would want to go farther up the Kardashev scale, and as they became a Type 3 civilization, they'd rely on something other than the power of their own star system. They would harness the power of several stars in their galaxy. With this much power, a civilization would have no problem meeting its ever-growing energy needs. They'd just hook up another star when they needed more power. If we ever advanced to this level, we'd have 100 billion stars available to harness in the Milky Way galaxy alone. A civilization like this would no doubt be the rulers of their galaxy, and they'd have the power to move entire star systems, merging them to harvest the energy they need more efficiently. So if one of these civilizations existed, well, you could detect them by observing the sudden disappearance of many stars in a faraway galaxy. This could be a sign that Dyson spheres have been constructed around not just one, but several stars. A Type 3 civilization could already be out there. After all, scientists have announced that they've found 2 galaxies with a highly unusual amount of infrared light. This is something we usually observe in galaxies where new stars are being born, but some unusual and sudden spikes in infrared light could mean that we've found the first signs that civilizations many times more advanced than us exist. Maybe they're about to make contact. Or maybe they already have. We might not be alone in the universe. Scientists from all over the world have their eyes and ears wide open trying to detect signals of life beyond our planet. But we're a bit tired of just sitting and waiting. So hop on our spacecraft because today you have a very important mission: to search for alien life. How would we prepare for this journey? What kind of life would we be looking for? And what would happen if we found it? This is What If, and here's what would happen if we went on a search for alien life. So far, we've detected over 4,000 exoplanets in our galaxy, and there may be as many as trillions. To make your expedition easier, you'd need to consult with NASA first. NASA has developed the Confidence of Life Detection Scale, or COLD, to measure progress in life detection research. The scale has 7 levels, ranging from signal detection to follow-up studies once life beyond Earth is confirmed. First, you'd need to look for biosignatures. This is physical evidence of past or present life on another planet, such as chemical compounds or molecules that indicate biological processes. If an alien astronomer was taking measurements of Earth, they'd look for oxygen and methane. Those are biosignatures that indicate life on our planet. If you're a celestial technology geek, you might scan for technosignatures. These are signs showing the negative uses of technology that cause artificial air pollution. This means aliens could figure out we exist because of all that smog we send into the atmosphere. Embarrassing, right? Now that you know what to look for, where would you look for it? You could start this search in our own cosmic backyard. Alien life could be hiding on the subsurface oceans of Europa, one of Jupiter's moons, or deep beneath the surface of Mars. Ground telescopes have already detected methane on Mars, sending probes to measure surface levels. That already puts you on the 2nd level of the cold scale. Or you could go further and look for alien life on rocky planets outside our solar system. You'd need to locate planets orbiting a star in its habitable zone. That's the area where a planet is not too close to the star and not too far, allowing for temperatures to be just right for liquid water to form. Scientists have already done the hard work for you here. Using the Kepler Object of Interest Exoplanet Archive, researchers identified systems that might have rocky planets that meet the criteria. They found 24 super-habitable planets. And one of them is very promising. KOI 5715.01 is roughly 1 billion years older than Earth, which means it's had enough time for life to develop. Scientists estimate that the best chance of discovering life is on planets between 5 and 8 billion years old. That makes KOI 5715.01 a perfect candidate. Now, while it's a bit cooler than our planet, it could support life if it contained enough greenhouse gases. Okay, so let's say you detected biosignatures on KOI 5715.01. Now, you've got yourself a potentially habitable exoplanet. NASA would then have to confirm that there were no measurement errors and that the planet really has the potential to host life. The next step would be to predict what type of source could generate such a signal. Scientists would need to confirm this signature couldn't have come from a non-biological source. Once that was done, you'd be on level 4 of the cold scale. At this level, scientists would test the signal with other advanced measurement methods. NASA's powerful James Webb Space Telescope would confirm the exoplanet contains a strong signature for life. And you would be able to proudly say you found alien life. And then scientists would be able to kickstart follow-up studies at level 7. That means you'd now be ready to fasten your seatbelt and see these aliens for yourself. But how would you get there? Yeah, that's when things get tricky. KOI 5715.01 is located almost 3,000 light years away from us. That's 700 times further away than Proxima Centauri, the closest star to our solar system. If we used developing ionic propulsion engines, it would take over 55 million years to get there. Wow. You'd have to make use of some futuristic solutions, like a laser sail. This technology uses ultra-thin mirrors to capture the momentum of light from stars and then uses this momentum to push a spacecraft to high speeds. If you managed to build laser sails with diameters of 320 kilometers, you might be able to reach KOI 5715.01 in about 8,500 years. Setting aside the fact that you wouldn't live that long, what would you find once you got there? Alien life could be extremely complex or very basic, and the alien's appearance would depend on the world they evolved on. Things like gravity, density, and the amount of energy given off by its star. They would probably have something that resembles fingers or tentacles to build tools, and since 2 legs and 2 arms are more efficient than 4 legs, the aliens might have evolved to walk upright. You want to invite them for a stroll? Well, first, you'd need to figure out their form of communication. And it might be a little more advanced than speech or writing. They might just exchange pheromones or even use telepathy. And finally, you'd want to know how they reproduce. We can't be sure if alien reproduction happens by seeding, fission, or egg laying, so maybe it's best to leave the romantic stuff here on Earth. While your journey to find alien life might be successful in our hypothetical story, in reality, it's still very far-fetched. With technology evolving to detect signals from outer space, we might be able to identify them at some point, but there would still be the issue of getting to them. What good does it do knowing something is out there if we can never see it up close? What if you found out that you had a long-lost relative? And what if that long-lost relative was from a different planet in our galaxy? And what if this faraway planet was home to billions of humans, just like Earth? But these humans don't look anything like us because they're from the future. Could aliens be future versions of humans? How far ahead of us would they be? How much would they have evolved? Would we be able to understand each other? And what would meeting future humans mean for humanity on Earth? This is What If, and here's what would happen if aliens were future humans. In 1947, a mysterious object crashed in the desert near Roswell, New Mexico. You all know this story, but could it really be aliens? The mysterious object was officially declared to be a U.S. Army Air Force balloon. But then, decades later, U.S. Navy Commander George W. Hoover, who had top-secret clearance, revealed that the mysterious crash involved time-traveling humans. Somehow, these future humans had developed the technology to overcome the technological limitations that prevent us present-day humans from making the same type of trip. Some theories suggest that these future humans travel back in time in order to understand their biological past. Maybe these same time travelers helped our ancestors to make huge leaps in scientific and technological knowledge in a relatively short amount of time. But if any of these theories are true, should we be prepared for another alien-human visit sometime in the near future? And what might we expect from this close encounter of the third kind? If aliens, future humans, were to come and visit us again, they would probably look similar to how they appear in movies. Like us, they'd still walk on 2 feet, but their heads and their eyes would be much larger. This fits with predictions of how present-day humans will continue to evolve. We can expect our heads to be bigger and our upper skull to become more rounded to accommodate a larger brain. And as our civilization advances enough for interplanetary travel, our eyes would get bigger so we can see better in dimmer environments that are further away from the sun. Future humans might also find a way to slow the aging process. So it would be possible to make several trips to places thousands of light years away within one lifetime. If we want to travel somewhere that's 60,000 light years away, and if our technology could do it, then it would be a 60-year flight for anyone on board. But when they got back to Earth, 60,000 years would have passed. We'd like to think that humans of the future would solve this problem so they could visit Earth and come home to tell their family and friends about their trip. But if future humans find a way to live for thousands of years, would that lead to a massive overpopulation on whichever planet they inhabit? Well, chances are, if they make it possible to live that long, they will probably succeed in optimizing their existence before that. Their civilization would undoubtedly be a lot more efficient than ours. The reason being is that they could be centuries, if not millennia, ahead of us in evolutionary terms. Future humans would be a lot smarter, and they'd have better technology to maximize their space and live in densely populated worlds without producing the same high levels of pollution that we do on Earth. In fact, you could bet that future humans wouldn't just have better technology, they'd be technology. Just like some humans today have implants to perceive sound or to detect atmospheric pressure, the humans of the future would likely have dozens of technological implants to make their lives easier. Think about everything your cell phone does for you. Now, imagine you could command it with your thoughts and that it would only be a small chip in your brain. A chip or implant like that might also explain why those who claim to have encountered aliens have said that the aliens spoke to them in their native language. Could future humans simply have automatic language translators implanted in their brains? Or would humans of the future evolve past different languages, instead using one universal language, like Esperanto?
What if the moon was more than just a lifeless rock? Under that bright light, it could be hiding an alien civilization. When did this alien life begin on the moon? What would these lunar dwellers breathe? And what would our neighbors look like? This is What If? And here's what would happen if aliens lived on the moon. Until Galileo showed up on the scene with his telescope, all we knew about the moon was that it was bright and shiny. While we certainly know more now, its origins are still a mystery. Yeah, we still don't know how the moon became, well, the moon. Some scientists think a chunk of the Earth broke off about 4.5 billion years ago after a violent collision with another planet. All the debris eventually came together to form this body. And the moon landing in 1969 did more than inspire humanity to reach the stars. It made this rock something real to humans everywhere. But we didn't stay for long, so what if the astronauts missed something big up there? The lunar surface is a rough place to live. Without an atmosphere, there's no protection from the sun's radiation, or even a way to keep oxygen on the ground. But maybe it wasn't always like this. After that piece of Earth broke off, microscopic life like cyanobacteria could have survived in this harsh environment. We call this the panspermia theory, the idea that life can be transferred by meteoroids, asteroids, or even spaceships. Considering the moon orbits us in the habitable zone, there could have been a time billions of years ago when it had fresh water. And volcanic activity could have released the gases needed to sustain life. So why isn't there life there now? Well, who's to say there isn't? When these conditions existed, the moon could have incubated life for hundreds of millions of years before humans existed. While dinosaurs roamed our planet, the moon could have been teeming with life that would look stranger than some of those behemoths. The moon's magnetic field is a fraction as powerful as the Earth's, so over millions of years, solar winds stripped away all of its atmosphere. With nothing to protect it, life on the surface would have to adapt to survive the sun's intense rays. On Earth, melanin in our skin protects us from ultraviolet rays, but instead of having a darker skin tone, the moon aliens could have developed new colors. Carotenoids are organic pigments found in vegetables like carrots, and they contain cells that protect against skin cancer. If the aliens evolved to have carotenoids instead of melanin, they might have tough orange skin that would resist the dangerous UV rays around them. And the differences don't end there. Since the moon's gravity is only 1/6 of that on Earth, these aliens could get around by jumping or gliding. But without an atmosphere holding oxygen on the surface, what would these creatures breathe? Well, even with an atmosphere that's only 1/100th as thick as ours, that doesn't mean that life can't exist. Recently, scientists have found a parasite that doesn't need oxygen to live. Maybe over millions of years, these aliens could have evolved in the same way, without breathing, well, anything. Now, while this diversity of life might exist on the surface, you couldn't say the same for the lunar oceans. I mean, if they existed. While the average ocean on Earth goes down 3.7 kilometers, the moon's seas would only have a depth of 1 kilometer. There's not much that could be found in these waters. But if life did exist on the moon, how would that have changed our history? Well, if these aliens had evolved before humanity, they might have visited us before we landed on the moon. And if they had waited until after the space race, the increasing tensions of the Cold War might never have happened. Instead, humans could have united in fear over an invasion from a superior life form. The militaries around the globe would have deployed countermeasures to assess the threats these visitors pose. And as scientists and politicians tried to communicate with our celestial neighbors, everyone else would be hunkered down, bracing for the worst. You know, sharing our corner of the solar system with a much more advanced civilization might be overwhelming, but it's either that or an all-out war. And considering how much more evolved these aliens are, we might want to think of a peaceful solution. Scientists have pieced together a pretty clear picture of what life was like on Earth thousands, even millions of years ago. But if you fast forward 1 million years from now, would alien civilization be doing the same to learn about us? What would Earth look like 1 million years from now? What remains of human civilization would still be around? And would we end up clones in a human version of Jurassic Park? This is What If. And here's what would happen if aliens came to Earth 1 million years in the future. We're living in the Anthropocene epoch, and in this historical period, the human impact on the world around us has been significant enough to geologically alter it. 100 years from now, it could be an era defined by ecological collapse and mass extinction. Big bummer, right? Now, there's no way for us to know how or when our species may take its final walk on our home planet. A team of alien scientists could find evidence of nuclear fallout, climate change, or maybe a massive asteroid that ended our existence. Or maybe they'd even find us already living on another planet. Maybe 1 million years from now, you'd be an alien on board a starship that has just entered into orbit around Earth.
I can't tell if you're joking or not.
But despite your best efforts to scan the planet below for intelligent life, you'd find nothing. Your trip down to the surface would be slightly delayed by an ongoing supervolcanic eruption. The planet would be blanketed in the darkness of ash. You might even have to wait a few years for your alien crew to clean it up before you could even land. Finally, you'd get approval to visit Earth. Down there, you'd find everything to be barren and lifeless. Storms, fires, and earthquakes would have erased nearly all signs of immediately visible life. But your team of archaeologists and paleontologists would know that if they wanted to find evidence of past civilizations, they better start digging. You'd be investigating what are called boundary layers. These are geological signatures that indicate a transition from one period to the next. So you'd be looking for animal and plant fossils, as well as changes in rock layers. You could find a thin layer of clay that marks the boundary to our Anthropocenic era. The top layer would contain not much more than small fossilized remains of a few plant species. The layer below would contain older rock, but not only that, there would be an abundance of diverse plant fossils. This would be a breakthrough for your team as they'd now confirm there was some form of mass extinction period. As you searched through this layer, the nature of what happened to Earth over the past million years would be revealed. You'd discover an unnatural amount of carbon deposits from fossil fuel emissions, evidence of global temperature changes, and widespread chemical pollutants. But the effects of climate change may have reversed themselves over the 1 million years humans have been absent. If your team were to uncover the regions where our coastal populations used to be, you could excavate the remains of cities relatively well preserved in the sedimentary rock. Imagine discovering the ancient subway tunnels and sewers of New York. But nothing you would find would be in pristine condition. Bricks would have gone from their characteristic red to gray, and steel would have rusted and dissolved, leaving only imprints in the soil. Finally, you'd make the biggest discovery of all: fossilized human bones. Just like the dinosaurs, these too would most likely only be found encased in sedimentary rock. Almost all of the fossils of dinosaurs that we discover today are from species that would have lived near lakes or rivers that flooded. Floods covered their remains in mud and silt very quickly, and this prevented their bones from rotting.
The same would apply to Homo sapiens. Your alien team would piece together the puzzle that many of these human fossils were the result of catastrophic floods or tsunamis. And based on how much these bones have fused with the rocks around them, your team could start to assemble a timeline of our unfortunate demise. Usually, bones take decades to decompose. If buried in a dry environment like a funeral casket, they could last for 100 years. Mummified bones can survive thousands of years. Finding any of these would tell your team that the last humans to walk the Earth weren't all that far in the past. But discovering only fossilized remains would reveal our extinction point being further back than you'd hoped. There wouldn't be any samples of soft tissues like muscles, just rocks that used to be bones. Oh, but you'd probably find fossilized plastic in the layers of sedimentary rock too. It's not yet known how long plastic waste needs to decompose into organic matter. It could take hundreds of years, maybe thousands. Or, as you and your crew could discover, millions. What you'd keep your hopes up for would be the real Holy Grail: human DNA. The oldest DNA samples found in our modern times date back 800,000 years and come from insects and plants. But studies conclude that DNA could take about 7 million years to disintegrate. And eureka! You'd find human DNA samples trapped in ice cores in what was once Greenland. Now, the big question would be, what do you do with them? Study human genetics for scientific purposes, or have a little fun? One idea would be to clone these ancient humans. You could even create some kind of Jurassic Park filled with people, except it would be called Anthropocene Park. And based on all that you'd put together about our tragic history, there would be so many entertaining things to do in this amusement park. Maybe you could clone other animals and play a game of mass extinction. The winner would be the one who could kill the most species in the shortest amount of time. You could dig for hidden oil reserves, increase carbon emissions for fun to watch icebergs melt. Or how about a game of nuclear war? Sadly though, you and the other scientists probably wouldn't be able to figure out what life was like for humans at the end of our civilization. Billions of years ago, another planet smashed into Earth. An event of this epicness could have created our moon. It also could have brought alien life to our planet. What evidence of this planet still exists on Earth today? Could there be life deep inside the Earth's surface? And could that life be an advanced civilization of humanoid aliens? This is What If, and here's what would happen if aliens are living inside the Earth. 4.5 billion years ago, Theia, a protoplanet the size of Mars, struck our young Earth. This collision scattered pieces of both planets into space, and many scientists argue that these pieces eventually coalesced into our moon. But what happened to the rest of Theia is still a mystery. The existence of blobs of material inside Earth's mantle, known as low shear velocity provinces, could be evidence that parts of Theia fused with Earth. These chunks are up to 1,000 kilometers in height and several times that in width. They sit below Africa and the Pacific Ocean, straddling Earth's core like a pair of headphones. But other theories, some dating back centuries, suggest a completely different explanation of what exists under the surface. A lush tropical paradise for aliens. The Earth consists of 4 layers: the crust, the mantle, and the outer and inner core. But there hasn't been any successful exploration below the crust, so there's much we don't know about the realities below the surface. This has led to spectacular speculation like the hollow Earth theory. According to this theory, our planet could be a series of nested spheres centered around a central core. In between these shells, atmospheres could exist that are capable of supporting life. In the 17th century, Edmund Halley, the scientist who discovered Halley's Comet, backed this theory. Many others have added to it, suggesting a small sun could be hanging in the center of the Earth, and plants, animals, and humans could be living there. And not just humans, but a race of superhumans. Immortals who possess sophisticated technology to build hundreds of subterranean cities. But if there were aliens inside the Earth, what would the conditions for life be? Could the inside of our planet be a luscious paradise? Or a hot, hellish dump? If you were to visit one of the low shear velocity provinces, you'd have to go 2,900 kilometers below the surface. Here, you'd be surrounded by magma or liquid rock, with temperatures as high as 3,700 degrees Celsius. And the weight of the crust and mantle above you would increase the pressure to over 237,000 times the atmospheric pressure, on the surface of the Earth. Whatever life you find here would need to exist in these extreme conditions. And these life forms would need to evolve to extract oxygen directly from the magma, or live without it. They'd need to survive without any sunlight. Radiation would be the primary energy source. And lucky for them, the radioactive decay of uranium, thorium, and potassium in the Earth's crust and mantle already account for the primary source of heat in the Earth's interior. There could be all kinds of undiscovered creatures down there, but until you could withstand the pressure and heat to find out, we'll never know.
Attention human, you are receiving an interstellar radio transmission. And it could be coming from one of the nearest exoplanets, Proxima Centauri b. What conditions make this planet a candidate for alien life? What types of civilizations could have flourished there? And should we expect them to be knocking on Earth's door any day now? This is What If, and here's what would happen if there were an alien civilization on Proxima b. At a distance of 4.2 light-years away, Proxima Centauri is one of the closest stars to our Sun. In 2016, a planet was discovered orbiting in Proxima Centauri's Goldilocks zone. That's where conditions for liquid water could exist. Meet Proxima b, a planet that registers at 0.87 on the Earth Similarity Index. This scale measures how similar a planet or moon is to Earth, and anything above 0.8 is considered Earth-like. As another example, Mars has an ESI of 0.64. In 2020, astronomers recorded a mysterious radio signal coming from the direction of Proxima Centauri. Could it be that an alien civilization was attempting to contact us? Though Proxima b is similar to Earth, life forms on this alien planet would likely develop very differently. For starters, the planet is about 20 times closer to its star than Earth is to the Sun. And it only needs 11.2 days for one full revolution. That's a lot of New Year's celebrations. But still, Proxima b receives about the same amount of solar energy as Earth. And that's because Proxima Centauri is an M-type red dwarf star. Compared to our G-type star, these stars are generally cooler, in a range of 2,200 to 3,200 degrees Celsius.
But there would be some extreme conditions that an alien civilization would have to adapt to. These extraterrestrials would need to be able to withstand radiation, and lots of it. The planet receives about 400 times more X-rays than Earth, and dwarf stars like Proxima Centauri give rise to coronal mass ejections that would blast the planet with lethal radiation. Without a protective atmosphere, this would be deadly for any potential life forms. Another challenge for a Proxima b civilization would be tidal locking. That's when a planet takes the same amount of time to spin on its axis as it does to orbit its star. Imagine living where you permanently face the scorching sun while the other side of the Earth is in a constant state of frozen darkness. This is what life would be like on this exoplanet. Civilizations on Proxima b would likely develop in the so-called terminator zones. These are the strips of twilight between the day side and the night side. Here, winds would carry warm air and create life-supporting conditions. And aliens would build thermal reactors with the mix of cool and hot water to have that H2O always available. But if civilizations appeared on either of the sides of the Terminator Zone, they'd need to develop different survival tactics. But collaboration and unity could allow them to supply each other with heat or ice effectively. And if a civilization developed on the light side, would they even know that there were other stars or objects in the universe? Would they even think about other life out in space? That brings us back to the radio signal the Breakthrough Listen project recorded in 2020. This signal occupied a very narrow band of the radio spectrum at 982 megahertz. This is startling because it's a portion of the spectrum rarely used by human-made transmitters. Researchers haven't ruled out the possibility that these signals originated on Earth, but there are many unanswered questions. One thing they're sure of, it didn't come from a natural world. Only manufactured or alien-made technology seems to produce signals like that. So, if an advanced civilization was trying to communicate with us from Proxima b, what would their society be like? They could be a Type 1 civilization like us and use the energy available from their planet, like oil, wind, or geothermal power. Or they could be a Type 2 civilization, using energy on the scale of their planetary system. That would mean they were thousands of years more advanced than us. Would they have developed complex languages and live in cities? Would they have democratic forms of governance? Or would they live under the rule of a dictator? You must have so many questions for our alien neighbors, and they would have so many questions for you. Or maybe they already know everything. Unfortunately, we likely won't be able to visit them anytime soon. Using current technologies, it would still take between 19,000 and 81,000 years to reach them. Of course, maybe they could travel faster than the speed of light and get here first. Just north of the Martian equator lies a 45-kilometer-wide impact crater that scientists believe may have been the site of an ancient lake. Here at Jezero Crater, scientists theorize that its frozen soil may contain the most significant discovery of humankind: life. On February 18th, 2021, NASA's Perseverance rover started searching this crater to find out if we're truly alone. What is the likelihood of life on Mars? What would these Martians look like? And how will we send samples back to Earth? This is What If, and here's what would happen if we discovered life on Mars. As Scientific American puts it, it would take a near miracle for Mars to be sterile. Astrobiologist Chris McKay at NASA believes that Earth and Mars have been sharing materials for billions of years. Kind of like using your roommate's spice rack. What? I thought you said it was communal. Comets or large meteorites that have hit Earth may have also sent debris onto Mars. A tiny fraction of this debris on Mars could have carried the same microbes that kick-started life as we know it on Earth. But what would this alien life look like? Many scientists agree that whatever life on Mars we might find would need to be incredibly robust. With the combination of radiation and freezing temperatures on Mars, could any life form survive such a harsh environment? As far-fetched as it sounds, microbiologists have discovered many organisms that thrive in extreme environments. The tardigrade, or water bear, is a highly resistant extremophile. It can withstand heat, cold, pressure, radiation, and even a complete lack of oxygen. There are also certain types of bacteria on Earth that rapidly produce spores when faced with hazardous conditions. The bacteria can then hibernate during an extended period of drought and withstand intense ionizing radiation. A team of 1,000 geologists, chemists, physicists, and biologists worldwide have drilled 4.8 kilometers into the Earth and discovered robust life forms. Mars has a similar geological past to Earth, so looking underground could be a great place to start. By drilling into the Jezero crater, we could encounter spores associated with a relatively recent geological era. And on future missions to Mars, we may dig deeper and uncover fully vegetative microbes. To find rock samples that might support life, NASA's Perseverance rover uses an array of lasers called a supercam. It can study the surface of Mars at a distance. One of the lasers will heat a rock sample and vaporize it. This creates a plasma that can be analyzed to understand its elemental composition. Another laser will reveal which compounds are in the dirt. If the supercam detects organic molecules or elevated concentrations of elements like nitrogen or phosphorus, the rover will head over to take a closer look. It will then scan the soil in greater detail to detect any organic material hiding in the dirt. NASA's team on Earth has only one shot at picking the right spot to gather these samples. With limited space on board the rover, only a few dozen samples can be collected. So, no pressure and fingers crossed. If all goes well, NASA plans to bring back samples known for preserving biosignatures on Earth. Biosignatures are faint molecular traces left behind by microbes billions of years ago. Once the samples are collected, NASA and the European Space Agency plan 2 missions to get them back to Earth. This involves blasting tubes of rock and soil samples into orbit to be collected by another spacecraft and then returned to Earth. Whoa, this looks kind of fun. If Perseverance's mission is successful, the discovery of life on Mars would be as groundbreaking as the discovery of DNA. In 1543, Copernicus boldly shook the status quo with his theory that the planets orbited the sun. His discoveries completely changed our worldview, no longer putting Earth at the center of the universe. Discovering life beyond Earth could be just as powerful. But not finding any life could raise more questions. Is the Earth truly special? Are we alone out here? Even if we don't discover life, these Martian rock samples will allow chemists to study the geochemistry, mineralogy, and foundational bedrock materials of Mars in detail. This could provide us with essential insights into the climate history of Mars and help us better understand Earth's climate as well. In 1976, 2 Viking landers became the first spacecrafts from Earth to touch down on Mars. They too probed for life in the Martian soil, and the results are still debated to this day. One experiment indicated that the Martian soil tested positive for metabolism. On Earth, this would almost certainly suggest the presence of life. But another related experiment found no trace of organic material whatsoever. While most scientists have not reconciled the conflicting results, the consensus is that there's no conclusive evidence of life on Mars. But several researchers disagree. Recent discoveries of terrestrial microorganisms surviving outside of the ISS indicate that life may be resilient enough for Mars. And methane in the Martian atmosphere could be a sign of microbial methanogens, a type of microorganism that produces a significant amount of methane. Stinky aliens. Mind you, it's possible that life on Mars didn't have the right conditions to start at all. Or maybe it died off from an extinction event, similar to the asteroid that wiped out the dinosaurs. Or it's even possible that we might end up finding life that was accidentally brought to Mars by one of our many rovers. Let's hope this Perseverance mission doesn't turn into a $2.7 billion facepalm. Do you ever feel like you're being watched? Not by a creepy stalker, but by aliens. Well, it might be happening. Just like we watch animals at the zoo, aliens may be out there watching us, like we're the zoo animals. But why exactly would they be doing this in the first place? Could they be afraid of us? This is What If. And here's what would happen if we lived in a galactic zoo. Imagine being trapped in a zoo. Well, if we really do live in a galactic zoo, then you'd already be in one. Aliens could be out there watching your every move. They may want to study the human race, or learn from our technology. Or maybe they're planning to attack us. But what if instead of attacking us, the aliens are afraid of us attacking them? Wait, what? If you've watched any sort of sci-fi movie, you may think of aliens as the bad guys. The ones who attack our planet and steal all our resources. Hey, shoot, get out of there. Get away. Go. But never mind humans being afraid of aliens. They may be afraid of us. Think about it. It's entirely possible that aliens have been watching Earth since the birth of humanity. If aliens have been hanging around since the beginning, think of all the horrible destruction they've seen humans cause. Deforestation, pollution, and let's not forget about war. Lots of war. Humans are constantly trying to kill each other. It's estimated that almost 1 billion people have died from war throughout history. So from the aliens' perspective, humans might seem like an incredibly violent, scary species. They may not want to make contact because they're afraid of how we might react, which could very well be with violence. And while aliens might be watching us, we aren't confined to a zoo. We have left the Earth and gone to the moon. But are we sure that intelligent life is even out there? Well, the odds are pretty good. The existence of alien life could be explained by the Fermi paradox. We have our sun, but in the universe there are billions of other suns. And they're billions of years older than our solar system. Orbiting these other suns could be Earth-like planets. And on Earth-like planets, there's a good chance of there being highly intelligent life. With so many worlds out there, there's an even better chance that at least one of them has developed interstellar travel. The Fermi paradox suggests that with interstellar travel, it would take a few million years to travel through the entire Milky Way galaxy. You may think that sounds like an incredibly long time, but if there's a civilization that is billions of years older than us, it would just be a tiny fraction of their history. So, if all this is true, which is very likely, the aliens may have already found us. And apart from us being a pretty violent species, we may not be interesting enough for them to make contact with us. We may just be another life form out of the thousands or millions that the aliens have seen. After all, if you see an ant colony on the ground, do you try to make contact with it? You most likely go along with your day. To other life forms out there, we may just be a simple group of ants. Ants they don't want to hurt or bother. Just observe. Another thing we have to keep in mind is how we communicate with the aliens. Ants in our world might be trying to communicate with us, but unless they send the right signals, we'll never know. The same goes for the aliens and us. We may not be communicating with the aliens the right way. They may not even know that we want to make contact with them, so they just leave us alone. What is the best way to communicate with aliens? We'll leave that story for another What If.
"120 light years away from us, there's an exoplanet that can potentially host life. It's called K218b, and it's a world you'd want to visit.